Hey everyone, welcome back to our today's R programming series. In today's video, we are diving deeper into time series forecasting by exploring two advanced models, the ETS model and the TBATS model. We will also learn how to access model accuracy using a split between training and test sets. So let's get started. Before we start, let's load the required libraries. We need forecast for ETS and TBATS model and T-series library for handling time series data, and just run it. And then next let's load our dataset. Here we are working with electric production data we saved in my PC with CVS form, and this is my file path. Make sure this path is accurate according to your PC and just run it. And you are seeing here the first few rows of our data. We're showing monthly electric production figures, and we'll use the second column, this column, as our time series data. So now we will transform our data into a time series object, setting the start year to 1985 and a frequency for 12-month data. So this is for the required code, and we're using here TS function for transform or converting data into a time series object, and we are using here 1985 as a starting point, and we're also using here 1. That means it starts from January, and we also used here the frequency 12 months. We make a plot of electric production, this time series. Just run this and look at the data. This is our time series data. Here the starting point is 1985 and January, February, March, and so on. So now we need to evaluate our models effectively. We will divide the data into training set and test set. We'll use the last 12 months as our test set, and for that this is the following code. Here we use the train set, which contains all data except 12 months, and we used here the test series as the last 12 months. Let's run this. And now first we will feed the ETS model to our training data, and for that this is the following code. Here we use the ETS function for setting the ETS model, and we also used here the forecast the ETS model, and then we use a plot for showing the ETS model. Let's run this and look at the results. This is ETS forecast plot. The blue lines represent the ETS forecast for the next 12 months, while the red dashes is the actual value from the test set. This visual comparison gives an initial idea of forecast accuracy. And just look at the ETS forecasting data, and you are seeing here this is showing us the forecasting data of the next 12 months. These are the forecasting points. So now we need to create the TBATS model, and for setting the TBATS model we used here TBATS function, and then we used here for forecasting the TBATS model, and we also made a plot. Let's run this and look at the forecasted values for the TBATS model. This is the forecasted value of next 12 months of TBATS model. Here just say, and this is the plot for the TBATS forecast. Here also the blue lines are showing us the next 12 months forecasted values, and the dot red lines are showing us the accuracy of the model. Finally, let's calculate the accuracy of each model forecast by comparing the forecasted value to our test set, and for that this is the following code. Here we use this accuracy for ETS forecast test series, and TBS accuracy is equal to accuracy TVS forecast tested this function we just use here. Let's run this and look at the results. As you see here, this is the matrix of accuracy for the ETS model, and this matrix showing us the accuracy for the TBATS model. And here the RMAC means root mean square error, and the MAE means moving average error. This gives us the insight into each model accuracy. Generally, lower values is better comparing the two, and you can determine ETS or TVS provide the best forecast accuracy. And just look at here, this value is 2.322 and this value is 2.21. That means here the TBATS model is better than ETS model. So in this video we covered advanced time series forecasting with ETS and TBATS model, evaluated their performance and interpreted the outputs. You can now apply these techniques to any time series data for more accurate and reliable forecasting. That's for today. Thanks for watching. See you next. Bye bye.